Hello everyone, my name is Pranav and I'm part of the Display and Color Technologies team at Apple. Today I'm going to talk about a new perceptual video quality tool, AVQT, which we recently released at WWDC this year. Alright, let's start by looking at a typical video delivery workflow. In such a workflow, the high quality source video undergoes video compression and optionally video downscaling to generate videos with lower bit rates. And these low bitrate videos can then be easily delivered over a bandwidth-constrained network. A few possible ways to use such workflows include AVFoundation APIs, such as AV Asset Writer, apps such as Compressor, or it can be one of your own video compression workflows. Now, downscaling and compression can add video coding and scaling artifacts, and this will impair the source video and create visible artifacts. One example of such artifact is blockiness in the compressed video, which is shown in the frame on the right side. Another example is when the video appears blurry and video details start disappearing. Such artifacts can adversely affect a consumer's video quality experience. Now, the first step to improve quality is to evaluate the quality of your delivered content. And the most accurate way of doing this is to have real people watch the video and rate them on a video quality scale. But this is very time consuming and not scalable if you want to evaluate a high volume of videos. Fortunately, there's another way. What we need here is an objective way to characterize video quality so that we can automate the process for speed and scalability. In such a setup, the perceptual quality tool will take the compressed video and the source video as input and output a video quality score. This score can be a floating point number in the range of 1 to 5 and mimic how real people would have rated the compressed video. To address this, we released a perceptual video quality tool at WWDC this year, and we are calling it the Advanced Video Quality Tool, or AVQT in short. Let's learn more about AVQT. So what exactly is AVQT? Well, AVQT comes as a macOS command line executable, and it attempts to mimic how real people rate the quality of compressed videos. You can use AVQT to compute both frame level as well as segment level scores, where a segment is typically a few seconds long. And of course, we have added support for all AVFoundation video formats in AVQT. This includes SDR as well as HDR video formats such as HDR10, HLG, and Dolby Vision. Next, we want to discuss 3 key attributes of AVQT that make it very useful across applications. First, we will see how well AVQT aligns with human perception. Then we will talk about AVQT's computational speed. And finally, we will show why viewing setup awareness is important when predicting video quality. Let's get into details for each of these. AVQT correlates well with human opinions on video quality, and it works well across content types such as animation, natural scenes, or sports. Now, we have found that traditional video quality metrics such as PSNR and structural similarity, or SSIM in short, typically do not work well across content types. Let's look at one example. Now, this is a frame from a high-quality sports clip, which is our first source video. Let's look at the same frame in the compressed video. You can see that the frame does appear to be of sufficiently high perceptual quality. Rightly so, it gets a PSNR score of around 36 and an AVQT score of 4.4. Next, we go over the same exercise for our second source video. The compressed video in this case seems to have visible artifacts. In particular, you should be able to see some artifacts on the face of the person. Interestingly, it gets a PSNR score of more than 36, but this time AVQT rates it around 2.6, implying poor quality. We think the AVQT score is the correct prediction here. Note that this is just one example we have picked to illustrate what can go wrong in cross-content evaluations. We wanted to test AVQT's perceptual accuracy on a diverse set of videos. So we evaluated it on publicly available video quality datasets. These datasets include source videos, compressed videos, and video quality scores predicted by human subjects. Here we will show you the results on two datasets, Waterloo IVC 4K and VQuake HD3. The Waterloo IVC dataset includes 20 source videos and 480 compressed videos spanning both coding and scaling artifacts. It covers 3 different video resolutions and 2 different video standards. The VQuake HD3 dataset is relatively smaller. It has 9 source videos and 72 compressed videos. And these were generated using video coding at 1080p video resolution. And to measure performance of a video quality metric objectively, we make use of correlation and distance measures. Pearson correlation coefficient, or PCC in short, measures how well the predicted scores correlate with subjective scores. A higher PCC value implies better correlation. And RMSE measures how far off the predictions are from subjective scores. A lower RMSE value would imply higher prediction accuracy. Now we want to evaluate how well can AVQT predict the scores given by human subjects. On the x-axis, we have the ground truth subjective video quality scores, and on the y-axis, we have scores predicted by AVQT. Every point here represents a compressed video. As you can see from the scatter plot, except for a few outliers, AVQT does a great job in predicting the subjective scores for this dataset. This is also reflected in the high PCC and low RMSE scores. And we see a high performance on the VQuake HD3 dataset as well. Let's move on and talk about AVQT's computational speed. Note that high computational speed is quite important to ensure scalability. AVQT's algorithm is designed and optimized to run fast on metal. This implies that you can run through large video files very quickly. It also takes care of all pre-processing natively. For you, this means you don't have to decode your videos and scale them offline. AVQT does that for you. The table here shows AVQT's execution speed for several video resolutions. We have recorded these results on an M1 MacBook Pro using HEVC compressed videos. You should note that AVQT runs through a 1080p video at 175 frames per second. So if you have a 10 minutes long 1080p video at 24 Hz, AVQT can compute its quality in under 1.5 minutes. The final attribute we want to talk about is viewing setup awareness. Your viewing setup can affect the video quality you perceive when watching a video. In particular, factors such as display resolution, display size, and viewing distance can mask or exaggerate artifacts in the video. To address this, AVQT takes these parameters as input to the tool, and then attempts to predict the right trend as these factors change. Let's take a look at one such case. Consider two scenarios. In scenario A, you are watching a 4K video on a 4K display at a viewing distance of 1.5 times the height of the screen. In scenario B, you are watching the same video on the same display, but now at a viewing distance which is 3 times the height of the screen. Clearly, in scenario B, you will miss out on some of the artifacts which were visible when you were watching it closely. This implies that your perceived video quality in scenario B will be higher than in scenario A. And AVQT can capture such trends and different quality levels. The chart here shows that as viewing distance changes from 1.5H to 3H, AVQT scores increase as well. We recommend you go over the README document available with the tool for more information on this. Let's walk through a demo on how to use AVQT. To download AVQT, visit the URL shown here and sign in using your Apple ID. You can then search for AVQT and download the DMG file. The DMG includes the installer and a README file. So I have already downloaded the tool and installed AVQT on this system. If you look at the output of which AVQT, you can see AVQT is placed in the user local bin directory. Now you can invoke AVQT help command to read more about the usage of different flags supported by AVQT. Let's see what I have in my current directory. I have a sample reference and a sample compressed video that I will use for the demo. So let me run AVQT through them. We will provide the reference and test files as input and specify an output file. Let's name the output sampleoutput.csv. The tool prints the progress and reports the segment scores on the screen. The default segment duration is 6 seconds, and since this clip is 5 seconds long, we have only one segment. Next, let's look at the output file. You can see the frame level scores here, and finally we have the segment level score towards the bottom. Now in the demo, we showed a few options, but the tool has several features built into it as well. For example, you can use the segment duration and temporal pooling flags to change the way frame level scores are aggregated. Similarly, you can specify the viewing setup using the viewing distance and display resolution flags. Also note that AVQT requires your reference and test videos to be spatially and temporally aligned. For any mismatch, AVQT would simply bail out. You can still force the evaluation using the force flag for such cases. To wrap up, here are a few important things that we want you to take away from this talk. AVQT is currently made available as a macOS command line tool, and we are currently working on a Linux-based tool. Please contact us if this is something you are interested in. Next, AVQT has a high perceptual correlation and reports around 90% correlation on publicly available datasets. It also supports both SDR and HDR videos. As we showed, AVQT is extremely quick to compute with speeds over 170 frames per second for 1080p videos. It can also take viewing distance and display resolution into account when predicting video quality trends. Thank you.
All right, and we're back, and I'm here with Pranav. Pranav, thanks for that great talk. Welcome.
Hi everyone, I'm Pranav from Display and Color Technologies team at Apple.
Thanks. Let's go straight to the questions. The first one, so any plans to release AVQT for Windows or Linux?
Yeah, so for the initial release, we released it to macOS based tool for Apple developers to enable them to evaluate video quality for compressed videos. Based on the feedback that we have received, we are now working on a Linux version so that we can run it on a Linux OS as well. And if this is something you are interested in, I recommend you contact us and get in touch with us so that we can help you provide the tool.
Great. This next one, I'm going to merge a few of them into one. It's kind of like a compound question, but the first part of it is, what are the weaknesses of AVQT, if any? And then I think a follow-up that I think we can just merge is that generally people are asking how it performs versus VMAF and SSIM plus. And another question is, yeah, can you compare AVQT with VMAF? So I think those all kind of go together. So I'll give you some time to answer that.
Yeah, sure. Yeah, in the talk, I talk about three attributes of AVQT. The first one is perceptual accuracy, the second one is speed, and the third one is viewing condition awareness. On the speed front, I think AVQT is doing a pretty good job. It's pretty fast, as you would have seen from the speeds that we mentioned. On the accuracy front, I think there is scope for improvement, and I think that's true largely for all perceptual video quality metrics. Especially for regions like when you have flat regions and you have some artifacts there, you have banding or blockiness. I think there's some scope for improvement, and this is something which we are currently working on to help improve this. And the third attribute is viewing condition awareness. And while this is a very large problem, I think there are opportunities to develop models specifically to target certain devices. And this is again an opportunity where we can build AVQT. For the second part of the question, comparing AVQT with other metrics like VMAF. So we have done some of our internal evaluation on publicly available data sets and some of the data sets that we have created internally. On accuracy front, we think AVQT is quite competitive with respect to VMAF, and we have computed scores like SROC and PLCC and RMSE to compare against VMAF. And on the speed front, we think AVQT is much faster as compared to VMAF.
All right. A follow-up from that first question is, how exactly do we contact you for the Linux version of AVQT?
Yeah, I guess I'll have to provide my email address. You can contact me.
I was going to say, you can also answer this in the comments after the live Q&A stuff if you want to like paste a link or something like that. It might be easier than spelling it out.
Yeah, I think that would be great. I'll comment an email ID there, and you can contact us on that.
Great. Next question is, do you have any plans to release the source code?
As I said, I mean, currently our plans were just to enable Apple developers, and we haven't really made a decision yet, to open source on this. We are actively monitoring the feedback that we receive, and so far it was like, can we get something which can run on Linux as well? And we're working towards it, but certainly we want to work towards greater adoption of AVQT, and we'll continue to monitor feedback on that.
Fair. Here's a question about the training. So was the mean of all viewers' score per video used when training the model, or was it an individual viewer score being used?
So the way we trained the metric was, we conduct a subjective study where one particular video is viewed by a number of people, and we aggregate the scores. So it's essentially the mean opinion score that was used to train the metric.
Okay, let's see. Next one here is, does AVQT take into account banding artifacts?
Yeah, as I was answering initially, it was designed for video compression and scaling. And while it tries to take that, I understand there are certain issues with AVQT right now, where when you have flat regions or smooth gradients, there are artifacts which AVQT cannot capture accurately. But this is again something which we're working on, and perhaps the next version of AVQT should be more robust in handling such artifacts.
And a question here is, just curious, why we need AVQT instead of simply improving VMAF itself?
Yeah, that's a good one. We think we were looking for something which runs much faster, and what VMAF delivers is, the accuracy is great. I think we have improved quite a lot in terms of accuracy, but we need something which runs much faster, and we were trying to build something which runs faster than VMAF.
Makes sense, yeah. So kind of performance.
Mm-hmm.
Another one here. Do you have any quantitative results on how well the viewing condition awareness correlates with human perception?
Right. We have conducted studies by weighting some of these parameters and have tested it on some of the subjective data sets. Again, as I said, there's quite a few variables here, and there are opportunities to develop it for some specific models. There are some gaps as well which we need to fill in. But yeah, to your point, we have some data around different viewing distances and devices where we have seen it correlates well.
All right. Was there a reason to select segment duration of 6 seconds?
Yeah, so the 6 seconds things comes from most HLS segments are designed to be around 6 seconds, and that's where we chose, because we felt that video developers and content creators might want to run this on HLS, and that was one of the examples which I presented in the talk at WWDC.
Yeah, that makes sense. An open-ended one, which is, generally, where do you see the state of the art in quality measurement going long term?
Yeah, I think there's still scope to make full reference metrics better. Like we need to come up with full reference metrics which are fast, as well as more accurate and more targeted for particular viewing conditions. And once we get past this, I think the next natural step is to develop no reference metrics. And so far, deep neural networks have looked quite promising. So if you can generate a large amount of ground truth with your full reference metric, it should be more straightforward to train a deep neural network and create no reference metrics. So yeah, I mean, in the short term, maybe focus more on full reference metrics, and in the longer term, we should have a no reference metric.
Makes a lot of sense. Here's a question related to HDR content. So have you compared HDR content AVQT with Delta E100 and PSNRL 100?
I'm not very familiar with PSNRL 100. Maybe Delta EL 100 is being referred to as Delta E 2000 metric with the reference of 100 nits. So Delta E metrics are more designed for color difference and not necessarily for video compression and scaling artifacts. So it might be quite different. The goals might be different, is what I feel here.
Got it. Got one comment came in, just says, thanks for an awesome Q&A so far. So just throwing that one in there before one. I think we have time for one more question. Let's see. Do you need perfect frame alignment between the reference and the test, or can there be frame rate differences?
That's right. So AVQT does need both spatial and temporal alignment, and this is a must. And if there's lack of spatial or temporal alignment, AVQT will simply bail out, even if there's just a minor difference. One way you can still run the tool is to use the force flag. There's a -- force flag in AVQT that you can invoke, and it basically forces AVQT to run and compute scores. Those scores might not have a meaning though if you do not have alignment, but still we provide an option for you to run it on videos even when they might not be aligned.
And I think that is all the time we have, unfortunately, for Q&A. And I say unfortunately because there's a lot of interest in asking you a lot of questions about AVQT. So I figure you can hop in the chat at facebook.com/@scale-events and maybe answer some of them in line because there's lots of interest here. And then you can also provide that email address for the big interest in the Linux side.
Yeah, definitely.
Yeah, so thanks so much for joining us. Thanks for preparing the great talk. Any last statements you had, Pranav?
No, I think that's great. We'll certainly monitor all feedback, as I said, and go over the comments that we have received.
Awesome. Well, up next, we have two more speakers, Balu and Yilin from YouTube, who will also be talking about measuring video quality in the context of UGC content.
Okay, sounds good.